I'm going to show you how to train a 500 million parameter large language model from scratch, pre-training, mid-training, and post-training, courtesy of Andrej Karpathy's Nanochat repository. A lot of the work has been done for me, and I'm going to show you the key steps that allow you to get this started and train within 4 hours for about $100. Here is the original repo. You can find it on GitHub under Karpathy/Nanochat. I've also forked a version which is publicly available and has a few tweaks. There is one fix to a folder creation issue, and I've also added in some scripts in the scripts folder here that allow you to push your results, your model and results up to HuggingFace using push to HuggingFace, and also pull down checkpoints from HuggingFace using pull from HuggingFace. If you don't want to spend $100 training this model, you can also just run inference on the pre-trained checkpoint that I've pushed up to HuggingFace, and I'll share below in the description. So I'm going to talk through now how you can get this repo up and running and some of the key features of it. Now, it does emulate what would be done for a large model like ChatGPT 4 or even 5, in that it has the modern phases of training: pre-training, which accounts for most of the 4 hours, 3.5 hours about, then mid-training on chat data, Smoltalk. That only lasts about maybe 10 minutes, and then there's a few minutes of post-training where it will run through the training splits of many benchmarks like GSM-8K. So most of the time will be spent on pre-training. Before that, we will create a tokenizer, which I'll briefly talk about as well. And the easiest is probably for me to just get started. So I've cloned the Trellis fork of this repo, and I have it here in VS Code. In the README file, you can find some good guidance from Andrej and some additional Trellis tips that I've put in right at the top, and that can help you to get started. We're going to use Runpod for this training, so I'm going to click on this one-click affiliate link. It'll bring me to choose some GPUs, and we will want to run this using 8 GPUs. So I'm going to run with Nanochat with 8 GPUs, and I'll get it started. And in the meantime, we can take a look a bit more at the template. Now, you can run this on 8 by, let me just show you actually the choices. I would recommend 8 H100 exams. They have the fastest interconnect, best flops. You could try and run an H200, but it's more expensive and the same number of flops. Same with B200, so I don't recommend those. If you wanted, you could also try to run on the A100s, which are down here, 8 A100s. But this is going to run more slowly, and I think will probably cost you more money because even though it's cheaper per hour, the number of flops is significantly lower as well. So I recommend running on any of the H100, PCIe, NVL, or SXM. Now, if you look at the pods here, let's just check out the template I have. I've added a start container command so that when you start up this pod, it's going to log you in with weights and biases, with HuggingFace. It's going to do some installations. It's going to configure your Git username and email, and then it will clone the repository here, and it will then execute all of the startup commands that Runpod will normally run. For this to run smoothly, you want to set a few environment variables. It's best if you do this via secrets, which you can set in the secrets panel to the left over here. So I've put in a GitHub personal access token, HuggingFace Hub token, that needs write access if you want to push the hub, my GitHub username, then my weights and biases API key. If you don't set this, things will still run. It's just you won't log to weights and biases. And I've put in my Git user email. Now, I've also set the home directory to workspace. By default, it would be set to root, and that means everything that's saved during the training will go to an ephemeral container rather than to the disk. So if you restarted your container, you would lose everything. It's important, therefore, to set the home directory here. It's not a huge thing, but it's a bit cleaner during install if you set Rust up in Cargo. This is to do with Rust installations, which are needed for doing the tokenizer training. I'll talk briefly about this. These last two fields here are automatically set by Runpod. So you should add these environment variables through secrets over here. And this pod should be up and running now shortly. You can check the logs. It's currently just downloading the image. And when the image is downloaded, it'll start to run the installations. Once the pod is up and running, we will move into the Nanochat folder, and we will just run this speedrun script, which I'm going to go through in a moment. Now, if you run this speedrun script directly using bash speedrun, which you can do, you will just see it running in the terminal. We'll have to SSH in first. But if you exit the terminal, it's going to kill the process. And for that reason, it's best to run using something like screen, or you could alternatively run it in the background using something like Python unbuffered, and then no-hub like this. And you could run bash speedrun and direct the logs into a log file like log.log or speedrun.log. And then you want to put the and sign. So you could alternatively run that. But screen, if you install it using apt-get install screen, you will then be able to run a terminal and detach. So once you've run using screen, you can detach from the session without killing it using Control A and then pressing D. So I'll show you that. And then outside of that, when you've detached, you can tail the logs and take a look at it there. Just another note here on weights and biases. If you don't set export weights and biases run variable, which will set the run name and weights and biases, then it will just set wandb run to dummy, and that will skip using weights and biases throughout the training. So I'm going to check my container. It should be downloaded now. Yep. And the container is started and everything has been installed. So we're going to connect in. And you could connect in VS Code. I actually recommend doing that because if you ever want to run part of the speedrun script, but not run other parts, it'll be easy to kind of disconnect. What I'm going to do is just get running in a standard terminal. So I'm going to copy this SSH here and I will pull over a terminal and I'm going to paste in that connection link. And to get started, there's just this command here. So I'm going to move into the Nanochat directory, install screen, and then run that command there. So it'll run some general updates, and now screen is started. And now we're already started with the training here. First thing that's happening is we're running through some installations. It's helpful if I show you now the speedrun file so we can follow through what's happening. So first off, we're installing UV. We're creating a virtual environment. We're activating it. We can move on down here. Weights and biases. If wandb run is not set, then it'll just be a dummy value and it'll skip weights and biases, but we have set weights and biases to D20. 20 is the number of layers in the model, by the way. And so that means we're going to get logging in weights and biases. Next up, the report template will be created, and then Rust is going to be set up because that's going to be used in order to train the tokenizer. Now, the way the tokenizer gets trained, I think it's only on about, 2 billion characters of the pre-training set. So it's a very small subset. The pre-training set is about, I think, 10 billion tokens when you train with the speedrun. But we only need 20 billion characters, which is only about 500 million tokens for training the tokenizer. And the tokenizer training is very simple. You can imagine just characters laid out like this, and it will search through for combinations, frequencies of adjacent pairs, and it will repeat that iteratively to come up with token suggestions that allow you to compress the representation. Because if you replace common pairs of tokens, for example, if there is very commonly I followed by A, then you can just have a token for IA, for example. So that's done recursively. And then tokens that are created also are checked with adjacent characters until you have got a set of tokens from which you will then select, I think, 64,000 in this case here. So we're using a tokenizer of about 64,000 characters in size. Now, things are already moving fast here. We've downloaded a lot of data. Unfortunately, in the screen view, it's not very easy to scroll up and down. The Rust tokenizer's already been trained at this point, so we've got 100% progress on training. And we have got some data here on the tokenizer, which is interesting. So the tokenizer that we are using is about 65,000 tokens. GPT-2 was 50,000 and GPT-4 was 100,000. So we're somewhere between the two. And actually, I'm going to detach here because it's very hard for me to read what's happening. So I'm going to do Control A and then press D. So I've detached, and I'm just going to log speedrun, tailf speedrun.log. And yeah, this allows me to look at what's being printed out. I actually wouldn't mind seeing some of the earlier part. So I'm going to escape from that and do tail-n 1000 and speedrun.log. And we can now scroll up more cleanly. The big trade-off that we're using here is we're not supporting certain symbols. So here, if we look at the compression, and the compression ratio here is how much compression we get by tokenizing instead of just using byte representation. And our compression ratios are good, but they're not as good as for GPT-4. You can see particularly on Korean language, we've got very little compression compared to GPT-4. And also we've a bit less compression on code and maths. So we're doing pretty well on English, for example. News, we're basically similar to GPT-4 and a lot of the other science. I don't know what FWE is, but we're taking some trade-off by not supporting some non-English characters. So that's the tokenizer. It was trained very fast. We're then moving to set up the model, which will have depth of 20 and training it on CUDA. And this training has already started. For the training to run, you need to have downloaded data from HuggingFace. The data is FineWeb Edu, which is a cleaned set of Common Crawl that is then further filtered down to the highest quality by using a language model to grade the quality as educationally high, medium, low. Actually, a language model is not used to filter everything. The language model is used to filter a subset, which is then used to train a very small classifier, and that small classifier is then used to filter all of Common Crawl. So we're using about 10 billion tokens of FineWeb. FineWeb Edu has got many more tokens than that. It's FineWeb itself has got maybe over 10 trillion tokens, and FineWeb Edu is a subsplit of that. I'm not sure exactly the size, but you can check on Hugging Face. Now that we've looked at the tokenizer training, let's just tail the run, speedrun.log, and we can see here what's going on. So if I expand this out, we can see training is underway. We're 1 minute into training. Our loss is about 6. That'll get down to just below 3, maybe 2.5 by the end. We're 0.14% of the way through training. Our grad norm looks pretty good, down around 1. That'll fall lower as well. You can also see the flops utilization. Flops utilization is a measure of the CUDA, how well you're using the compute of the GPUs. And it's quite interesting how Karpathy does it, because it's very hard to directly measure the flops utilization. So what Karpathy does is on the denominator, he will consider just the spec sheet number of flops in BrainFlood 16, which is about, I think, 979 or something like that, 976 teraflops. So that's on the denominator. And for the numerator, he'll measure the rate of token throughput, which you can see here, about 1 million tokens per second. And then for every token, he calculates based on the architecture how many flops you need in attention in the MLPs. And when you multiply that all together, you get a number of flops per token. So if you know flops per token times tokens per second, you can calculate the numerator, which is the flops per second, and the denominator is the spec sheet. And that allows you to calculate flops utilization. And flops utilization here is very good. If you read through the repo, you can find that anything above 40% is going to be really good. And that's what we're getting. So even the big labs, I think, if they get above 40%, obviously the higher the better, because you're better using the GPU, then you're in good shape. So we are in good shape here. Now, if I go across the weights and biases, I should be able to find some logging. So let's go to weights and biases here, wandb, and I'm going to check the projects tab. And hopefully, yeah, Nanochat is up here. And we can see training. We've got mean flops utilization, training loss, grad norm. We don't have a whole lot of data here showing just yet. But we can see that the validation split is 3.3. Sorry, it's 3.3 and the training loss is 11. So as it turns out, yeah, I mean, this is just an early data point. Our training loss is actually lower, because we can see that, well, it's lower at this point, but I guess the data point that's recorded is a higher training loss. So I'm going to leave this now. I'll come back again in about 3.5 hours, and this should have done the pre-training and moved on to the mid-training. The mid-training is going to be a lot faster. It's on a Smoltalk split of conversational data, and then also some training splits from benchmarks. And then there's a very short post-training. So we'll get to see that in a little bit. But for now, everything I think is up and running. And so I can just head off And we'll come back. I'll talk about the mid and post training, and I'll talk about how we can then do pushing of the weights up to hub, and finally run our Nanochat chat interface. It's been a few hours now, and the training is going well. We're done with pre-training, and I want to just show you the transition here. So right around 100%, which is, let me expand a little bit and increase the font size. So you can see training finished after 3 hours and 6 minutes. And the loss came down to 2.71. The grad norm of 0.1786. And the validation bits per byte is 0.8120. So bits per byte is how many bits it takes to represent a byte, every byte of input text. And I believe GPT-2 is actually a little bit above that. So this is kind of around the vicinity of where GPT-2 performance is. And when the pre-training is done, then a series of evals take place. You might recognize some of these, like GSM8K. I don't know if that's in there. No, that's not tested just yet. Common Sense, ArcEasy, HelloSwag. So you can see it's starting to score on a lot of these. And then it moves on to do the mid-training. So we've got a core metric of 0.222, which is aggregating over the other metrics. And then we move, you can see here it's just finishing pre-training. And it's moving on to mid-training. So mid-training is on a conversational data set called Smoltalk, mostly. It's also got a few of the training splits from benchmarks. And that's underway now, but it's going to be a lot faster. You can see it's up and running here. And we're already at about 73% in just 5 minutes. So while I'm chatting to you now, this is probably going to finish. And then there's going to be a set of evals. And after that set of evals, there's going to be post-training, which is even on less data again, because it's just on the training or auxiliary splits of common benchmarks. Although the easier benchmarks of today, it's not doing humanities last exam, it's not doing ArcAGI 1 or ArcAGI 2, but it's doing some of the more common, easier benchmarks. And so we'll see those results pop up as well. Now, I'll let that go for a few moments, but I want to show you when we are done, we're going to try and run the chat interface. And we're also going to start to push some of these checkpoints up to hub along with the report as well. So for that, I have added in 2 different scripts, pull from HF and push to HF. The pull is going to be relevant if you don't want to train and you just want to grab the checkpoints that I've put up on HuggingFace Trellis/Nanochat. And if you want to push up your own, then you can adjust the organization name from Trellis and use the push to HF script. And it's easiest if you just go again to the README and check out here, uploading the scripts. You're going to upload separately the base, the mid checkpoint, the SFT checkpoint, and then you can optionally push up the report. And you definitely need to push up the tokenizer as well, because you'll need that if you're going to run inference. For downloading, just a note that probably if you're downloading, you're not going to have run all the installs and training. You do need to run the installs and training. So for that reason, just make sure that you run this series of commands, including UV sync, which should sync all the requirements. And then you can start to pull from HuggingFace. You can pull the SFT checkpoint is probably the best. And then you can pull the tokenizer as well. And optionally, you could decide you want to pull the report there too. And when that's done, we're going to run python-m scripts.chat_web. And that's going to start up the chat interface. And I've exposed on the Runpod the 8000 port. If you use the template, that will happen automatically. So all you need to do is copy the pod ID and you should be able to get up and running. So if I go over to Runpod, you'll notice here under Nanochat in the settings, I'll have exposed, you can see here port 8000 in addition to the ports that are normally exposed. And I'm going to grab the pod ID here and I can just paste that in so that we have it ready to open up the chat interface when we're done with the training. Now, the next thing I'll want to do is this, but I'll want to run it within the screen that we have created. So I basically want to restore the original screen. So I'll close out of the logs, restore the original screen, and then I'll run the chat interface. Now you can see right here, it looks like we've finished now the mid-training. It's done right here. And we are now generating our splits of data for the post-training. And there's some data being downloaded here from ArcEasy, ArcChallenge, for example. These are some benchmark results being run. And I think we're now, if we're not running some more evaluation, yeah, I think we're still running possibly some more evaluation, building the model configuration. You can see it's loading the model from the mid checkpoints, step 809, which should be the final step that we have up here, which it is, 809. And when we started the mid training, that should have loaded the model from the base or the pre-training. So you can see when we started mid training, it loaded step 21400, which was the very final step, hopefully, of the pre-training. You can see here 21400. So everything should be loaded, and it should be now. It looks like it's running some metrics. Then the post-training should occur, and we should run some final metrics then. So I'll just give it a few minutes. Okay, so I'm back, and that mid-training and the post-training has now been completed. I'll just quickly show you here. After the mid-training, all of those evals have completed. You can see them completing on each rank, and then it gives a final score. Actually, I think a final score here. So it runs all of those, and then it moves on to post-training, which is very fast. And it'll just go through a relatively small amount of tokens. It takes 700 steps. And at the end of that, it runs the evals again. So you see right here, it's going through ArcChallenge, GSM8K, human evals, spelling bee. And now we're pretty much done. Report.md should be there. I can stop tailing the logs. I can take a look at report.md if I like. So here's the report. Let's scroll down through it. So we have the Tokenizer training, 2 billion characters. The special tokens took about a minute to train, so very fast. Comparison with GPT-2, comparison with GPT-4, we talked about that earlier in the video. Then the base model training hyperparameters are all set here. Details of the base model loss, the bits per byte, 0.8, which we already talked about. And then we have the evaluation results for the base model. Next, the mid-training, and then it's going to show us the post-training down here, which is the chat SFT. And for the SFT, we're only training on the loss of the assistant tokens. So that is a key difference as well, typically done in the final post-training stage. And the total time was 3 hours and 47 minutes. Most of that pre-training, as I said. And here we have the results, which I think look broadly similar to what Karpathy had. So we'll exit out of this. And now we're going to try and chat. To do that, we will open the screen again. Now, it may or may not be still running. Yeah, so that screen is actually finished because we've completed all the operations in that screen. So it is closed down, which means we're going to want to run this script here. But first, we will need to activate the environment. And we'll also probably need to set the base directory. So I'm going to activate the environment here, just like this. You should see Nanochat appearing. And I might even just paste this down here, just so people have the benefit. And the other thing I need to do is I may need to specify this value here, Nanochat based here. And I'm going to see the best way to do that. Yeah, it's probably this approach here. So just going to export Nanochat base directory. This will help point it to the weights, home, and then cached here in Nanochat. And I think this should be enough to get us running. And hopefully all going well. It should start up on port 8000, which it has. Beautiful. And all I need to do now is grab this Runpod proxy URL. I can go to my browser and paste that in. And here we go. Here's Nanochat. And let's start off and say the capital of Ireland is. Let's see what it, oh, wow. That's phenomenal. Yeah. Tell me a joke. That's not a joke, folks. Okay. 1 + 1 equals 8. All right. We do have some numerical issues here, but broadly, this is looking good. Capital of Germany. Berlin. Wow. This is nice. The results are looking pretty good. And I mentioned we might want to push everything up to hub. So if we do want to do that, we can run these scripts here. Again, it will have been helpful to have set the Nanochat base directory if you want to run this. So I'm just going to add that in for people's benefit here. And I'm going to copy all of this and we will push it up. Let's go back. And I'm going to close down the server here because we're done. And now we can hopefully allow everything to push up. There are a few gigabytes. I think the model is about 2 gigabytes because it's 500 million parameters times 4 because it's in 32 bits. And we will also upload the optimizer as part of the base model. I think the optimizer will go up for each of the stages actually, so you could literally continue to pre-train. That there is the base model being pushed. Then the midpoint is now being pushed. And then the SFT will be pushed. And then the tokenizer will be pushed. And then the report should be pushed. So that's the order of operations. Tokenizer's last actually. And if we go up to HuggingFace, you should be able to find it. I'd pushed some data previously. So you can see this is all uploading. There's a previous version. That actually was a bit buggy because I had to stop and start because I ran into issues when I was just trying to run it by myself first time through. But hopefully now we should see the SFT data point is pushed, which it is. The tokenizer will be fast to push up, fairly lightweight, just a megabyte. And the report should also be pushed up. So if we just refresh here, everything should look fresh. And the report we can check. And the tokenizer then we'll give a quick check as well. So you can see here the final report. It's got everything that we want. And let's go back and check out tokenizer. And this here looks like it is not being updated, but that may well just be, yeah, that's just because the tokenizer is deterministic. If you rerun the tokenizer script, you should get the same tokenizer because you use the same shards and BPE is deterministic. It will run through and find pairs and keep on combining pairs in such a way that it keeps providing compression. And so that process, there's nothing stochastic about it. And that's why it's saying that I haven't pushed anything new because what I pushed earlier this morning is deterministically the exact same. And that brings me to the end of the tutorial of how to train your own model. It's a small model. It's not a very powerful model, but as you can see, it does generate good quality English, at least. Where I see this as particularly useful is this if you want to try different optimizers, you want to try different architectures, you can affordably train the model. That's the big benefit of this, in addition to the educational purpose of being able to go through the different portions of the code and see a little bit how some of these really large models are trained at scale. I'm going to put links to the Nanochat model I've pushed down below in the description, as well as a link to this repo and Karpathy's original repo. Let me know any questions, as usual, down below in the comments. Cheers.